I'm Beth Smith, and I'm with Texas Instruments. I'm the education technology consultant slash rep, but I really we don't really sell directly, so I really am here to help, whether it's a teacher or a school or a district or the state, math, science, STEM, and coding. And taught math in Jacksonville, Florida, for 25 years, and I've done some TI basic coding, and I'm just really learning a little bit with Python, and have maybe limited experience using the microbit. But I'm excited to share with you guys just maybe a little bit of venture, and I would love just to let you know the whole connection with the TI Nspire, our handheld calculators. I'm going to be using the teacher software just because it's a much better visual in this remote environment. And I will say, I'm not sure whether y'all are using Inspires in your classrooms or you're using the TI 84s. The last 5 years I was in the math classroom, I taught with the Inspire, and I would never go back in the classroom without it, just because of what it does for conceptual understanding, math and science. But the 84 is an awesome model too. And our 84 plus CE, I'll go ahead and just show you guys that real quick, in case going forward, we now have Python edition. So all the 84s that are purchased from this point on should be the Python edition. I don't think there's a lot out there that are not. And the microbit does not work yet with the CI84, but this fall we do hope that it will. And just a little bit about what is, I had to really think about it. Okay, to grasp what a microbit is, and help me with this as well. Let me just see where we are with people. So there's still only a few of you guys, but in a nutshell, it's almost like a little mini computer. It's obviously small, and it's like a micro mini computer with your processors and your inputs and your outputs. And again, just share your thoughts with that in the chat box. And if we really look at an overview of it, you can see that we now have the microbit 2. And so that's what we're going to be looking at now. And to me, it's amazing to think this little device that costs $15 or $16 has lights, it has sounds, it has a microphone, and the radio antenna is going to open up a whole new world, even of some data collection, or perhaps communicating with each other. Okay. And so, it really is kind of like that microprocessor, so to speak. And so what we're going to do with TI is we're going to go through and just write a small code, and we're going to take this as far as y'all want to. It's hard doing this more as a demo when everybody doesn't have their own to work with. So I just encourage you to please use the chat menu as you come in with that. And so let me just say a little bit with this, and we'll copy one in a minute. You can basically take any of this code in Python and copy it right into the TI Nspire. And what I'm excited about too is when we think about the value that it's going to have in the math and the science classrooms. And I'm one of those people that feel like that coding should be embedded into the curriculum. It should be a part of the math curriculum, part of the science curriculum. And because it's teaching that procedural fluency and really helping them prepare regardless of what they do when they get out of high school. I think they're just really going to have to almost know that as another language, or at least understand the thought processes behind that. And you can see right here that sooner or later, perhaps we can establish that connection. I think the other cool thing is that I think over time, the Grove sensors, which are they're very, very inexpensive sensors, also have the ability to work with this as well. So getting started a little bit, we're going to play some, but what TI, like all of our lessons and activities and resources are free for you guys on the website. So whether you're using the handheld or computer software, we do have an app, a Chrome app for the 84. It's a little bit limited in what it can do. So all of our resources are there for you. And we've come out with this whole concept of 10 minutes of code or TI codes. And we have it for the Nspire, the 84, we have TI Basic, we have Python. And the nice thing about coding on the Nspire and the 84 is that it's menu-driven coding. So it's natural to go from that drag and drop that we see with Scratch and maybe some other programs, go into that menu-driven coding where you don't have to worry too much about whether it's a capitalized letter, if that matters, or spaces and things of that nature. So, and this is the TI codes for Python. And they're really, really nice because they really step you through. And we're actually going to look at Unit 6, which is coding with the microbit. And we're going to go through and look at Skill Builder 2. We won't complete all that coding together, but we will begin to do with it a little bit. And so I would like to show you, let me get here. This is weird. Oh, sorry about that. Working on two screens can sometimes be tricky. So I'm going to go ahead and open up. Y'all can see my little microbit right here. And basically when you plug it into a handheld, one end's going to be, this end is going to be, as you see up here, going to be your micro USB. And then when you plug it into the handheld, you would have a mini USB. And so this is just a really simple program that we can write together, so I can show you how easy it is. But we're going to print I love TI, and then we're just going to look at how would you display that image of the heart and add music and things of that nature. So if I run this before we start programming it, so this happens to me a little bit. I was playing with this morning, and so what I need to go ahead and do is, I think it turns the microbit off, or let's see. There we are. We're going to eject this. And then I'm going to unplug it and plug this back in. And then go back over here and try to run this again. Well, let me shut this down. Open this. Sorry about this. Let me just. I have found a little bit when it goes to sleep, it tends to disconnect some. So welcome, Ernie. Oh, I'm excited to see that you, and just please contribute in that chat menu. All right, so let's open this up and see if we can't get this running now. So if you guys can hear that and see the, let me get this live. I think you can hear that, but I need to open back up the document camera. There you go, much better. So you can really see what's happening with that. And so let's look and see. I'm going to press escape to end this. And then what I'd like to do right now is we're just going to go ahead and write that program. And so that's going to allow me to explain a little bit about how this works with the Nspire, or further on, it'll be with the TI-84. And so the Nspire is menu and document driven. So it really does function more like a computer than it does a handheld. And what I'm going to go ahead and do is I'm going to press the Dock key. And I'm going to insert a new problem. And so basically what that means, like any variables I had or any graphs or anything, it's all going to start fresh with the new problem. And this program editor would be TI Basic. So that's also menu driven, but I'm going to go ahead and add Python. I'm going to click new. And I'm just going to type sample. And I'm going to click OK. And so here we have our Python page that we're going to write our code on. And the first thing that we have to do is we have to import the microbit piece, so the microbit module. And so this is what we basically created to go with microbit. And before you use the microbit with the Nspire, you do have to put this module, load this module on it first. But as I said, it's menu driven, so I'm going to go menu, and I'm going to go more modules, and then microbit, and from microbit import. And so my understanding of modules, and like you guys said, I said earlier, y'all may have more experience than I do, is it's basically just a module is just a bunch of a group of code, so that you wouldn't have to go back and do that over and over and over again. Okay. And so the first thing, if we go back and look at what we did, is we want to go ahead and tell it to print I love TI. Now, if you know the syntax, yes, you can go ahead and type that out. But again, as I mentioned before, it's also menu-driven coding. So if we go to menu and go to more modules and go to microbit, and I want to go to, now if I go somewhere and I'm not sure and I need to back out, I just press escape, display, and I may mess up here, so that's not an image. I'm trying to think of where print was. Let's see. So in order to not look, and I'm just going to type print for right now, so you'll have to forgive me. As I said, I'm still kind of a little bit of a novice with this. I'm going to do print. And so we know that once we type print, anything we put inside the parentheses and the quote is what's going to print. And then we have to have our quotes, and then I love TI. Now, if I was doing it from the keypad, keep in mind that this is not a QWERTY keypad, because if it's a QWERTY keypad, then they cannot use it on standardized testing. And that was what we saw print on that page. And then I'm going to go ahead and press enter. And so what we have to do now is we're going to put in that, if we go back and look at what this command was, we're going to get the while get key. And that's basically saying when we press escape, that tells us that we're done. And so we want to display the image heart. And so there's some built-in images that are already created. And then we're going to play some sound. And so we want to play, what is the pitch? All righty. And then that sleep and how long do we want that pitch to play? And that sleep of 500 is basically pause for a half a second and then display the small heart and then do your pitch. And you could get students to play with the pitch and a lot of cool different things with that. And so now I'm going to go back over here. and we go to menu and more modules. And here's our while command. And then press enter. And so one thing that I've really had to learn about Python and is that the fact that all the indentations and things of that nature really, really matter. And so you see those two little gray diamonds, that matters. And so now we want to say we wanted to display that heart. Okay, because again, this is, if you look over to the right, that's the small heart, but that's what we want to do. And so menu driven. So where would we then go? Menu, more modules. Whoops, I'm going to press escape to get out of that a little bit. And then display. And so we want to show an image. And the image that we want to show is a heart. And so again, that heart was already built in, all righty? And so we can kind of go back and look as we're doing this to see, you know, which ones are built in. And so it's always going to be menu, more modules, and microbit for probably 95% of what we do. And then you can just look at this, images. And so in set 1, you can see that we have, these are just basics. And when we created all this, probably just went ahead and kind of took some of that code from the microbit site and kind of built this in. And so we can do heart. And then we can press enter. And so again, this is, I guess, really kind of on the same level of the heart. So that's why we have 2 diamonds. Again, please feel free to interject in that chat box the whole concept of programming. All right, y'all are being kind of quiet with me. And so now we want to do some music. And so again, we can take what? We can do menu, more modules, microbit, music, and there's our pitch. All right, so you get an idea of what you can do. So what is the frequency and the duration? And what I like about this is it says, okay, you know, if you saw that pop up, you've got a frequency of 0 to 800,000. All right, and so we'll type in 150. And milliseconds, so again, if we do 50 milliseconds, that's what? That would be if 500's half a second, think about what that would be. And then you do have to move outside this parenthesis and then go to the other line. Now, what's tricky about this is we have to be careful here because we're still kind of on the same level. So we don't need that last indentation space. So we're going to have to go backspace. And we want to do sleep 500. So we want to sleep for half a second. So that's where sometimes it may be easier to do sleep 500. All right. And now we're going to do the small heart. And so we press enter. And again, we're going to go menu, more modules, microbit, display, images. Oops, hold up. I think I have to go here first for methods, show image, and then go back. So the students get really comfortable. I've done a lot of coding, not with the microbit, but with our TI Innovator Rover, which is like a robotic car that I can show you guys a little bit about. They get very, very comfortable as far as, you know, the menu-driven coding, and they get very, very fast with it. And so, hold up, where was I? I think I need to go microbit, display, images, set 1, and then heart small. and press enter. And so now let's go copy this. How would we go back and copy it? Well, the nice thing about the Nspire is it works just like a computer. So I can come up here and hold that shift key down and just copy that. And just like the command on the computer would be Control C to copy, Control V to paste, that also works. So I can just go Control C, and then I can arrow down here, and then just do Control V. And then we just need to arrow back, and maybe let's make this a little bit higher pitch and press enter. And then let's go back and just copy this. So if I'm on the computer, it's really nice because I can just select it and copy it. And then we want to print I am finished. And so once we get, it's going to start out doing what? Let's think about what it's going to do. It's going to go, I love TI, and then it's going to do the sound with the flashing hearts, and then I am finished. And let's just come up here time-wise, because I really want to get you guys to look at some really cool data collection with this. And so in order to run it, it's going to throw it on that the shell page to run that. If I go to menu and I click on run, you can see the different options. And so I'm on a Mac, which is why it's saying command versus control. But just like you have keyboard shortcuts on the computer, on the Nspire, whether it's the handheld or whether it's the computer software, you have keyboard shortcuts. But if I click run, it's going to throw me over to the shell page, alrighty, and run it. Now, here's the issue, and this is a little snafu on my end. I've got to figure out what I'm doing wrong. I've been getting this, when I was kind of practicing this morning a little bit, I've been getting this runtime error, which is a pain because I have to eject the, here it is, eject this. Got to eject my micro bit real quick. And then I'm going to try to plug it back in. Let me just save this real quick. And so it's going to make me close this out. And so that's something on the software end, and I apologize for that. I just did not get a chance to troubleshoot that too much. And it may be some code I'm not putting in there as well. All right. Okay, so do y'all see any mistakes with this? Because it may be on my end. It looks pretty much the same as we did on this one. Try to eject this one more time, and then I'm going to go Let me open up. Sorry, I had this working just a little bit ago, so thank you for your patience. And I think that it may be the issue with the software versus the handheld. I just thought the software would be a lot easier for me to show you guys on. Okay, now we're getting it. So it's just I had to restart it. But I think you get the drift with that. And then we finish. So a couple I wanted to show you. One other concept, as far as I'm not sure whether you guys have had a chance to look at the different options as far as activities. On the website for Microbit. Have y'all looked at any of these? Yes, classes do need to go. So there are just tons and tons of fun activities that you can literally cut and paste. And so if you look at this beating heart right here, they have quick little videos, and then they have the video too that talks about the drag and drop. And so if you look at the code, that's what we just did. So you could literally copy and paste that. All right. And so I want to show you a fun one, and then we're going to show you how that copy and paste goes. And again, if I mess up if the software messes up, we're just not going to worry about it. Let's see. I think it was we can look at the die. So I'm going to click on this. And here's the Python code. And you're going to shake it, and it's going to display random integers. And so I'm literally going to copy this. And I'm going to paste it in a new problem. And we should be able to call this dice. Oh, whoops. We'll do dice too, because that's what we're going to look at in a little bit. And I'm going to do Control V. Now, if we look at this, it looks pretty good compared to what it was on the website. But what do y'all notice that we're going to have to change? What's different about, let me blow this up just a little bit. What do y'all see? When I copied it, it put these random boxes. Do y'all see those? And so we just need to come in here and get rid of them. All right. So we should be able to run this if we just go Control R. And this is still, sorry, this is frustrating me, obviously, but we're just going to go with it. And I only have one more program to run, so it won't be that big of a deal. We'll get to recents. Okay. And then let me see if that was the same. Yes. And we're going to go Control R. We're still getting the same issue. I had this working before, and my plan B would be to put it on a handheld, but I can't do that right now. So it's going to see if it was working on the. Okay. Okay, so if we shake this, let's see, did I not do Control Run? So now I'm, okay, did y'all see the 6? Now do y'all see what it's doing? So this is working. And so you shake it and you just are doing random. So I want to take this to the next level, and let's see if we can't get a program where they're actually kind of simulating rolling a dice and to collect some data. And so this would be like an awesome thing to do. And so we're not going to write a code. I'm just going to go through and really talk to you about what that code is going to look like. And I think I may have a loop going on here, but that's okay. And so you're still shaking and what? It's not letting me press escape. Let's see. And we're going to force quit this. Okay, so last program. We're not going to write it because it's already written. And again, I apologize that the software was not cooperating with me. I'll get with our folks with that for sure. All right, so let's get this back up. So there's some. Okay, so I think this is where this can open up a whole new world of data collection for kids. And again, I think that the nice thing about it is that you can kind of use your judgment is how much of the coding do you really want them to do, and how much of the coding and I think that just depends. Do you want to kind of put in there for them? And so I want to talk about this program. Let's see. And so this was from TI Codes. And so I'm going to pop this back up and really let you see what our TI Codes program is like. And actually, even in Texas, teachers can get the computer science certification by working through some of this. And so this was Skill Builder 2. And the whole concept was, let me go back to the first step. What I like about this is, I don't know if y'all can really read this on the screen, and I will put the links in the chat in my email. But you're going to learn to use the buttons and gestures and then write a program that's going to toss the die and collect the values in a list. And so if you guys have worked with the 84, the Inspire, you know how you can put, a list in there and then you can analyze it. And what's nice is that as you go through these steps, I'm going to have to get this a little bit smaller to show you what it looks like. And you can do handouts with this as well. It goes through and it just explains the fact that we're going to use the buttons. So on that front of that microbit, you have buttons A and B. All right. And you're going to press the buttons A and B, and it's going to randomly roll a die. And so it tells you, it doesn't just say do this, do that. It tells you what you're trying to accomplish and how you're going to accomplish that. And so it talks about how there's that accelerometer on there, the chips and everything that are in there, which I'm still learning about. And again, we always have to start with that microbit import module. And again, we talk about the fact that we have to escape out to get rid of it. And every step you go through, you can see that they have the steps with, how are you going to access that menu? So you're going to go, menu, more modules, microbits, buttons, and logo. And on the right, you can see that they have the screen as well. All right. And so we could play with this. But again, I really want to show you guys the end of this. And then you're going to roll a die. So if we go back and look at the code from this, we also had to import a module for it to basically be able to do a random integer. And so basically what's going to happen if we look at this and understand what's going on with it is that you're going to press button A. And when you press button A, it's going to generate a random integer from 1 to 6 that's going to show up on the microbit itself. All righty. I kind of shut out B, that was part of it. And it's going to store, that should be tosses versus losses. Let me go ahead and change that. It's going to store the tosses in that list. All right. So hopefully this was going to run without me having to shut it down again. I'm going to go ahead and click File Save just in case. And we're going to go Control R. And I don't know why it's making me do this. This is very frustrating. So again, I apologize. So obviously we need to fix this bug and come out with a little bit of new operating system for the software. Oh, what? I think it was this one, yeah. So I'm going through all these different problems to make sure I have the right program. That was the shake one. Here we go. So I'm going to press button A. Because remember how I said every time we press button A, it's going to basically choose a random number between 1 and 6. Now, what I want to show you is on this page, I can put another page in here, and I'm going to put a data and statistics. And I don't know if you guys have ever played with the data and statistics page on the Nspire. It's amazing. And we're going to do tosses. And so what's awesome is we're randomly selecting integers, or we're randomly rolling a die. And it's graphing that data as we roll it. Now, we know that every time we roll it, each number should have the equal chance of getting chosen, right? And so I can probably, there we go, much better. And so over time, what should happen? Put that in the chat box. Yes, I love this. This has opened up a whole new world to collect data. And so over time, what should happen? The law of large numbers would say what? And again, you can have your students code as much or as little of this as you want to. And so we're getting lots of ones, but if we do enough, we should be getting them pretty equal. And so you could do it with coins. You could do it, we could go back and change the amount that we're doing with or anything. And I think this is going to be awesome just because I know you guys are in Georgia, and y'all are coming out with new standards too. But Florida just released their final standards, and that the whole data analysis and data collection and understanding big data is huge for all of our students going forward. If you really think about the ability now to gather data and to be able to analyze it and to talk about what it means. And, I think just doing little simple activities like this could be huge for our students. And all with this little guy. All righty. And again, that would plug into the handheld. And I apologize, the software was shutting down. I just thought, like I mentioned, it would be easier to display with that. I would love, I know we just have a chat, but I would love some input and conversation in the chat menu as far as where do you guys see this in the math or the science classroom? And have y'all done any cool activities on the website not from TI, but from the microbit? What are some of your favorite activities that you've done with your students on this site? So this is what's hard, living in the virtual world where y'all can't talk. Any questions or comments? Beating heart, yep. And that was, yeah, and Richard, the beating heart, Sababu, that we did that at the very, very beginning, which was really, really cool. The radio projects, okay, so where are those radio projects? Can I type that in the search menu right here? Richard, does that work? Were these some of the ones you were looking at? Awesome. Okay, so you can play the animal tracker, build a prototype radio animal tracker. So let's look at this, and we can try to copy and paste it, but let me see if this will play. And y'all need to let me know whether this is
It's great to use your microbit to create prototypes of devices.
Y'all hear that okay?
And this is a prototype of a polar bear tracker, which could help to send important information to scientists about how the numbers of polar bears and their behavior is being affected by climate change. Using the accelerometer on the microbit to detect movement and sending a signal via the radio to other microbit receivers, scientists can monitor a female polar bear's movements. For example, finding out if she is moving less and so maybe making a home so she can have cubs, or if she is moving around a lot to find food. Let's open the MakeCode editor and write the program for the prototype.
So I want you to look at that. The whole concept of teaching these kids this thought process is that we want their brains to grow, and we want them to be able to identify problems in their world and to be able to solve them. And so we do it on a microscopic scale, but it's that thought process and it's those visions that then help them going forward. Yes. Yes, Dan, I love that concept. I was just up in Paulding County last week, and we did some programming with our rover, our robotic car, and I'll show that in a little bit. And I will say, I think that if we look at good things that have come out of this pandemic, is that I feel like teachers are going to be much more willing to try new stuff, even if it's out of our comfort zone. And I always say, if we don't know something, ask one of the students in the classroom, whether it has to do with programming or whether it has to do with a computer issue, or I can't find this button on the graphing calculator. They know. I mean, and they're not afraid. And I was telling a couple of the teachers, I said, just send me an email and we'll jump on a Zoom call. And I think that's another cool thing, is I think that from a perspective of us being able to help each other, whether we're in the room next door or we're a couple states away, we're now much more comfortable jumping on a Zoom call. And the step fitness tracker, yes. So that's where I think they put it on their shoe, right? And they track. Let's just see again how to copy and paste this in here. Yeah, so let me see if this is going to work. I'm not sure if we have the radio, but we're going to try this. And what I'm going to do is I'm going to open up a new document. And I'm going to put in a programming editor, and we'll call this Bear. So and we'll see what happens. And I saw that break. I know I got that error, but let's just see what happens with this. No, okay, so that was what I was worried about, as far as that we had that, there's that radio module. And I know that with TI, we're going to be importing more and more of those. All right, so that was, remember we had to do the microbit import that I said you had to download. We just don't have that radio module in there yet. All right, so I know just a little bit, let's go back and look at some of those other activities, a step tracker. And again, what you can do is you can just come in here and search for it pretty easily. I did see that earlier. And so which one of these was it? Was it is it one of these? Step counter. And again, if they could do this, and it's really cool, but if the students aren't going to do some of the coding, I think it's important to kind of work through and say, okay, what are all these doing? Okay, so let me show you just a little bit about I actually may, be able to open this document to I'm going to deviate just a couple minutes away from the microbit. And I'm trying to see if I have. So we have a rover, and we have our own microcontroller. And I know a lot of you guys said Raspberry Pi. So this is called our TI Innovator Hub. And it's also a microcontroller. It's like the Raspberry Pi or Arduino. And it has a sound card on it. There's inputs, outputs. So a lot of the Grove sensors, I'm not sure if y'all are familiar with the Grove sensors or not. They're very inexpensive. You can get a temperature sensor, a light sensor. Those will plug in there as well. And so that's what's inside our TI Innovator rover. And so we're programming the robot. We're going to program on the calculators. It's either got to be the TI 84 Plus CE or the TI Nspire CX to drive. And so imagine if you're in the geometry classroom and you get the students to draw a square, and then they're telling you the sum of all the exterior angles and what is the measure of each interior angle just through exploration. And what's awesome about this, the first time I was ever in a classroom with this, it was the students that had the lowest grades that were the most successful with this, because they weren't afraid to try. They were using their brains, and and then those students that are those memorizers that like hit that brick wall, eventually they struggle, and it really yanks them out to make them think. And I do have a virtual rover demo that we set some of these down, set some of these up for, because we were, in that virtual world. And so it's really, really cool, because if you import that virtual rover module that's in part of that program now. And so these are just amazing to do with students. And if we go back and look at the, that was again, another modules that we had. And so also just with our STEM projects, I think that I don't know if you guys are familiar with those, but we have a lot of activities for these. My favorite activity with the rovers, the distance, rate, and time, where students really develop that conceptual understanding of slope and connection between velocity and speed. And then we also have a lot of projects as well. And it's, we, like you said, you love the bear activity, Richard. This is awesome too, because they really go through and look at some of the issues in the world around them. So like there was a pet alarm car, and then there's the flow of blood through the heart, which is really just the flow of current. So lots and lots of activities there. Anything else on that you guys would like to share with others that are on here? So I'm going to go ahead and put my email in the chat box. And let me get over there. And like I said, we are consultants, because we're here to help you help your students' brains grow. That's the bottom line. And so any questions you have, please reach out to me. I've been setting up Zoom calls to make sure teachers know how to update their graphing calculators. Before I went and visited Paulding last week, we spent an hour updating the innovator hubs, making sure the rovers worked, updating all the 84 CEs, and we just did it via Zoom and walked them through that. So that was huge. The other thing is, I know with the ESSER fund, the CARE Act funds, those are funds that every district gets. It just depends on what your district is doing with those. And with ESSER 2 and ESSER 3 funds, 20% have to go to learning loss. And so whether it's a TI graphing calculator or whether it's a microbit, that's education technology. And you can address a lot of those with the learning loss, just because the concept that we do need to, we have to fill those gaps. We can't just not teach what students needed to learn over the past year and a half. And, I think we can all attest to that. So questions or comments, and please put this in the chat box. What do y'all think? Where do y'all see, just the last minute or two, some ideas of how do we embed coding into the math classroom and the science classroom? How have y'all done it? Any comments or questions on that? Okay, that's about all I have. Thank you guys for your patience with the software. I hope that you've maybe learned something today, or it's given you some good ideas with what to do with your students. And like I said, I think that using the graphing calculators with this, that there's a lot to be said, because there's no computer, there's no outside distractions, and we have a lot of schools that are able to buy, with the COVID money too, calculators that kids can check out to take home. And so it's just really cool to be able for them to take it home and work with it too. So, yeah, so Dana, reach out to me and send me an email, and I can send you some ideas with, there's lots of options with just coding in general with our TI codes. I didn't go over just simply with the graphing calculator, TI basic coding. And they always say, if you know it, you can code it. So you could actually get them to code the Pythagorean theorem, or code the slope formula, or code some geometry formulas where they have to understand, okay, you're going to input the value for A, you're going to input the value for B. And the rover in the math classroom is huge. For graphing concepts, geometry concepts, that's another biggie. All right, thank you guys so much. I'll stay on the last minute or two if y'all have any questions.